everyone, my name is Kunsong Zhao. Today, I will talk about our paper, Imbalanced Machine Learning for Crash Field Readiness Prediction. My presentation includes the following four aspects. First, I give some background of our work. Software products may well contain faults upon release due to the complex program structure and some uncontrollable factors during the process of software design, development, and configuration. Once crash is triggered, the system will automatically generate a crash report to record the corresponding status information. Fixing crash faults is a critical task for software quality assurance. The stack trace is a set of frame objects that consists of runtime inspection and a list of function invocations collected at runtime. Previous work proposed an automatic method called Creator to predict whether the crash field residence is inside the stack trace or not. However, the number of crash instances that reside inside the stack trace is much fewer than those that reside outside the stack trace. That is, the data have the inherent characteristic of class imbalance. Next, I will describe the method used in our work. Magic learning is a similarity learning that reconstructs the original data into a more reasonable latent space to measure the similarity between crash instances. It's expected that crash instances with different labels are less similar, while the crash instances with the same labels are more similar. The Euclidean distance of two crash instances is defined as the first formula, where I is an identified metric, and the improvement version, the M distance, is formalized as the second formula. However, it gives the same weight to all pairs of the crash instance without considering the corresponding label Y and Y hat. In order to deal with this problem, previous work optimized the magic learning formulation by decomposing the loss function into multiple parts according to the labels of two crash instances in a pair, which can be formalized as this formula. And figure 2 gives an example of the effect of the two loss function. And by considering different losses for the crash instance pairs under discrete sceneries, we have the following loss function. That is this formula. Here I will present this side performance indicators and the results of our work. We use a public data set that includes 7 Zhao projects and use the 3 performance indicators to assess our method. We particularly designed 3 research questions to assess our ML method. The first one is, does our ML method perform better than sampling-based imbalanced learning methods? We designed the following 9 baselines for comparison, and the experimental results and the statistical results show that our ML method is more effective to achieve significantly better prediction performance for this task than the sampling method. The second research question is our ML method superior to ensemble-based imbalanced learning method? And we designed the following 5 methods for comparison, and the results show that our ML method performs significantly better than ensemble method for crash field readiness prediction task. The last research question is, how does our ML work with different classifiers? And we designed the following 10 baselines for comparison. The results showed that the KNN classifier with k equals 3 is a good choice for our ML method to achieve a better average performance for predicting crash fault readiness. And finally, I make a conclusion of our work. In this work, we propose a crash fault readiness prediction model based on our novel machine learning method called ML. And ML learns high-quality feature representation with a m-distance-based machine learning method and checks the class imbalanced issue by assigning different weights to the loss functions of crash instance pairs according to their labels. And the experiments showed the superiority of our ML method. And in the future, we will adapt our ML method to a cross-project prediction scenario. In addition, we plan to investigate the effectiveness of our method on more projects and real crashes. And thanks for your listening.
Good. Welcome back again. There was some problems, as you could understand. Any case, so first of all, Hong Kong, do you have any insights on the efficiency of the approach?
Yeah, I see. The whole model will be built in a short time, and because it's a machine learning model, and the whole experiment will be finished in about 1 or 2 hours. And I think it's more quickly.
Okay, so okay, perfect. As far as I understood, by reading your paper, you experimented with 8 projects individually, meaning that you computed metrics on those 8 projects, and then build individual models within project models to make predictions. Do you have any insights on how your approach would work in a cross-project scenario, meaning learning from external projects, building a classifier to work on a new unseen project?
Yeah, the main aim of its work is to build the model and with the one project, and we split the each project with 3 parts. The test set, the validation set, and the test set, training set. So we built a Weixin project model. But for the cross-project model, like you mentioned, and we will adapt our method as a future investigation.